We're going to use what we've learned in chapter 6, 7, and the first part of 8 to answer some economic examples together. We're going to look at some optimization problems. Read the question in front of you. Read the question on the slide. It's a good idea to try it yourself, especially parts 1, 2, and 3. Try and figure out what they are or guess what they are, and then we can go look at the solutions together. It's a good way for your mind to see what it knows, and actually remembering information, recalling information, successfully figuring out the answer is a very powerful memory tool. All right, question 1 is asking us, what is the marginal revenue of 1 extra pound of fertilizer? So if we look at this expression, we can really break it down into 2 parts. It says that profit is equal to revenue. What's revenue? Well, it's price times quantity minus cost. So marginal revenue is going to be the change in revenue. Let me write number 1 up here so you know which one I'm talking about. The change in revenue over the change in fertilizer. 1 extra pound of fertilizer. A pound of fertilizer per acre is our unit N. And so the answer here is going to be price, which just acts as a multiplicative constant, times the change in this function here, y is a function of fertilizers. So the first derivative of that, y prime n. And what's y prime n? How do we interpret that? The increase in wheat from 1 pound per acre of fertilizer. Question 2, what is the marginal cost of 1 extra pound of fertilizer? Well, similarly, we have cost in our profit function, and this is the term right here, so we're always going to subtract the cost from our profit. It's Q multiplied by N. N is the amount of fertilizer. Q is the cost per pound of fertilizer. And so what's the change in cost with respect to the change in fertilizer? I see here this should actually, instead of a Q, let's call that an R, so it's a little less confusing. R is the cost of 1 pound of fertilizer. And I see I have to change it right there. And so the cost is just going to be R. So that's the answer to question 2. What's the marginal cost of 1 extra pound of fertilizer? It's the cost of a pound of fertilizer. Really straightforward. That's because of the example. It's not always going to be that straightforward. 3. What is the marginal profit of 1 extra pound of fertilizer? Well, I told you profit is equal to revenue minus cost. And marginal profit is equal to marginal revenue minus marginal cost. And so marginal profit is just going to be equal to Py prime n minus R. So there we put all of it together, added some economic intuition to this expression. Let's continue with example 1. Now we're actually given a detailed function. So instead of just general function, we're actually given some specific values. And the one I'm thinking of is we now know what the production function is for wheat. We also know the price of wheat and the cost of fertilizer. So in this example, the farm is a price taker. So they have no influence on price. They're just fixed. Question 4 says, use the new production function, y of n, to measure how much fertilizer will maximize profit. So why don't we rewrite our profit function. Profit function is now equal to price times this thing. So that's price times quantity minus, oh, and I guess I could get rid of the price and actually add in the price of a bushel of wheat, which in 1950s was $1.40, minus the cost of the fertilizer, which is 18 cents a pound. We want to find the n value that is going to maximize this thing right here and give us the highest number possible for profit. Now let me simplify this just a little bit before we go any further. We're going to have negative 19.068 plus, we've got 1.4 times this number here minus this thing, and when we put that all together we get 1.1976n minus 0.075, or I should say 0.7 n to the power of 1.5, or 3/2. Now we're ready to take the derivative. And if I want to find the maximum, we know it must occur at a critical point. If the maximum point is in the interior of the interval. Now this question, n can be anything from 0 pretty much up to infinity. So I expect that the maximum point is going to be on the interior of the interval. And that's what we usually have with economic problems. And so what we're going to do is we're going to look for a critical point. And I'll keep it plural. We're going to look for critical points. And how we do that is just set the derivative equal to 0. And when we do that, when we set this derivative equal to 0, we're going to get 1.1976 minus 0.105 square root of n. Now let's solve for N, right? That's the quantity of fertilizer. So let's solve for that. We end up with divide both sides by 0.105. And if I take up my calculator, I get 11.406. And now I square both sides. And I get 130, maybe 0.1 rounded. I'm going to add a star. So this is the profit. Well, this is a critical point. This is a critical point. Now, is the critical point a maximum? Well, there's two tests that we could use. We know this is the first derivative right up here. So why don't I use the second order condition. And I'm going to take the second derivative, and it's going to be equal to 0, negative 1/2, 0.105 over the square root of n. So I got that from over here, and when we look at this, we know that n has to be greater or equal to 0, but it's not going to be equal to 0 because then there's not much point in doing any of this work. And then this thing wouldn't be a number either, so that wouldn't be very good. If n is greater than 0, the second derivative is negative for all n greater than 0, and it is including n is equal to 130.1. So we could plug 130.1 into there, but I'm not going to bother because I know that the answer is going to be a negative number, and therefore pi is concave, and the critical point n star, is a maximum. Extreme value. Now, question 5 asks us to calculate profit. So we want to know what is profit when we're using 130.1 pounds of fertilizer per acre. Now that's a rounded answer. If we look back at the function, I have to go way back, it's right here. And we wrote it again right down here. So off screen, I moved some things around. We've got our profit function. What's profit? It's going to be negative 19.068 plus 1.1976 times 130.1 minus 0.07 130.1 to the power of 3 over 2. I end up with a profit of 32 well, let's just say 32.9. Depends, might depend a little bit on the rounding. The next part of the question asks us to sketch the profit function. I put it into my computer software, and this is what I came up with. It looks like we've got the right answer. If I look down here, this looks like it's about 130 to me, and the maximum profit is about 32. And we can see that this thing is definitely a concave function, so the math analysis we did not lie. This is definitely a maximum, and we already showed that this is a critical point, and we know it's a critical point because I could draw a tangent line, which is a horizontal. I could draw the tangent line, and the tangent line at that point is a horizontal line, so I know that pi prime n is equal to 0. It's a critical point.